So here I'm basically trying to make sure that Firefox is the best quality, and in Debian I'm breaking stuff. So I'm doing the other thing. And I would like to say also that I'm a diving instructor, and I think it's quite important in the Linux community to say that, from what I understand. So I won't explain you what is Clang, what is GCC, and so on. It would be a waste of time for everybody. So the current status in Debian, what we've got, is pretty much all the C, C++, and Objective-C code are built with GCC. For every Debian architecture, we have something like 13 official architecture and 3 kernel. I should update the slide. We decided to get rid of Earth today, but that's a different story. I guess you now all know what is Clang, so I'm just going to explain that quickly, but it's just a compiler based on LLVM. It's designed in C++, and I know that all Linux kernel love C++. So what I've been doing for the last few years is trying to build Debian with Clang instead of GCC. So I've been using this crappy method for the last few years. Of course, it was GCC 4.6 the first time I tried, so it's very crappy, but it works. One of the goals of Clang is to be completely compatible with GCC in terms of argument. Not all features are supported on purpose. Some of them will be, some of them won't be. And this stuff is working. So for all Debian packages, they will think they will build with GCC, while instead it is Clang. So we have some packages, obviously, which are going to fail, because in Clang we are in version 3.5, and some people are expecting a compiler with version 4.8, something like that. So we have some crappy error like that, but it is just a few minor cases. So what we have been trying to do is to recompile the archive. We are not testing performances. We are not testing if the build is faster and slower. We are not testing if the binary are okay. We are not even running the binary at the end. But we have some unit testing in Debian, so that helps. So we know that most of the code that we are generating are working and can be executed without too many issues. So you can see, yeah, you can see the number. So we are pretty happy to show this result. So we published something like last week, the result with a new Clang release. So we dropped from something like 9.6 to a bit less than 6% of package failing in Debian. So currently in Debian we have something like 21,000 packages in the archive, and only a few thousand, only 1,000 is failing now with Clang, which might sound a lot, but it is still a huge improvement from what we started initially. So I'm going to explain what kind of failure we found while rebuilding the archive. I'm not a compiler guy. I'm maintaining Clang and LLVM, but I have no idea how it is working inside. I'm just doing the plumbery around. I'm just making sure that it can find the header and so on. So if you have very specific question on the compiler, don't ask me that. I won't be able to answer. But I know the basic, and I know what kind of error we found in the archive. So we found various issues. So the first one, which is quite common, is using variable length array. So from what I understand, it has been introduced by the GCC developer when they were introducing the ADA support, and they saw that would be cool to have that inside because ADA needs it, and it won't be very expensive to add that to C. They made a huge mistake because now a lot of upstream projects are using that, and it's a pain to not use that and to remove that stuff in the Linux kernel. Inner functions, which are not also part of the C standard, are very easy to fix this one, but we can find that in many projects. One of the common mistakes that we found, well, it's not a mistake, but one of the common issues that we found is that Clang is defaulting on C99, which is not the case of GCC. And GCC accepts a bunch of invalid C and C++ code. Not many C code, but a lot of C++ code. So for example, the default argument management in GCC is not correct. There is some scoping issue in C++ classes and so on. So it's a very specific issue. So we find only 1 or 2 cases in the Debian archive. But it is a funny issue to fix. One of the common mistakes that we found, and I know that this one might be surprising for some of you, is this kind of error. No upstream project should build by default with those kind of flags. So -w all and -w error. I know that intuitively you want to do that, but please don't, because every compiler is adding new warning, both GCC, Clang, Intel, and so on. So it's usually a mistake to enable that by default. You should only enable that once you are developing. For example, in Clang, in each release, we introduce 2 or 3 more warnings, which cause some error. Some of them are very minor. Some of them are a pain to fix. So I presented that slide and that stuff during the last Linux Plumber solution. And for the anecdote, Linus was in this room and he complained about this example and said, this example is crap. And it was the first person to speak in the room. So it was very, very nice from him to start with this kind of comment. But that's true, this one is crap. And it has been a pain for the kernel developer. But still. So how we have been able to fix that many bugs? So we decided to go different ways. So the first one and the most obvious one is fix upstream bugs. So some of them are very easy to fix. For example, with GCC, this example, if you start to build this code is crap. We all know that, and I think we all agree on that. GCC won't trigger a warning, which is an error. GCC should trigger a warning by default. Clang, because of C99, is considering that it is an error. And it is refusing to build that crappy code. So I had 2 students, and it was a great test for the GSOC students to start and to dig into and to show me that they understand what we were trying to do. So in most of the cases, you just add a 0 somewhere. Sometimes it's way harder because it can be API and you have to understand which error code you must return and so on. But this one is pretty easy to fix. I won't go into all the errors that we fixed, but some of them are interesting. So we found some wrong main declaration. So we found many different in the Debian archive. I don't know how people are expecting the compiler to behave, but still. So the next one is the opposite of the one I just showed you before. So we have a void function and we return a value. So GCC is not unhappy about this declaration, while Clang is considering that as an error. We have also the variable length array in plain old data element. So I think you all know what it is. And it is not part of the C standard, this one. This one is actually C++, but it's not standard either. And this one is a pain to fix. And the next one is because of C99, the behavior of the inline is different. So if we have an inline declaration in the C file, we should add a static. So it's very easy to fix once you know how to fix that, but when you are building a package which takes one hour to build and you get this error, it's harder. So what we did during summer, so I had 2 students working on that, one from the US, who is actually half French, and the other one, another guy from Russia, and sorry, Ukraine. And so now I had another student working from Russia. That's why I made a mistake. He's not in cream. So they fixed almost 300 bugs, and we had 90 of them uploaded into the Debian archive. So Debian is a very slow project. I think it's even worse than the kernel. So things are moving slowly, and maintainers, sometimes they don't care about toy project or other developers. So most of the people uploaded the fixes without any complaint. I just had one guy saying that what we did was crap and inner functions are great and we should just go away and stop that. I also think that the switch to Clang by FreeBSD and macOS X helped a lot because many upstream projects want their code to work on this platform, so they also been working to improve those fixes. So we won't take all the credit for the improvement of the Clang support by various upstream projects. So we also took another way to improve the thing. So we hacked into Clang directly. So I'm myself an upstream hacker on Clang and LLVM, so it was easy to get the patch applied upstream. So this one is one of my favorites. It has been fixed for the last 2 years, but I still love it. So some upstream things that the bigger the integer value you put in -O, the better optimization you will get. I don't think that's true, but we have one package with libdbi driver which has a -O20. So in Clang we return an error. So you can consider that an error. I didn't have the feeling that we should trigger an error. A warning is fine and just fall back on a specific value. So we are falling back on -O3 because -O4 is not doing anything in Clang anyway. So we fixed 50 packages thanks to that. One of the stuff that we did during the summer, and it's not me, it's a student from the French-American guy who did that, and he's only 19, so It's pretty cool from a 19-year-old guy to be able to fix a compiler which is shipped by default on one of the major operating systems. So what he did is basically, instead of returning an error in Clang 3.4, when you are dealing with unknown optimization flag, which make no sense in Clang, for example, no defer pop. In Clang, it doesn't mean anything. In GCC, it has a meaning. So we decided with the LLVM community to, instead of returning an error, just to say, okay, we don't know this flag, and just trigger a warning. It's pointless to fail the build here. And the next one is the same kind of stuff. So instead of returning an error, we just consider that UTF-8 is a default in Clang. It has been forever, so there is no point to failing because we can handle UTF-8 here. So one of the stuff that I learned during summer, I guess most of you knew that before, but I didn't. GCC, when GCC doesn't understand an argument, it's going to pass that by default to the linker. So it has some interesting side effect. Clang, we don't do that. Instead, we trigger an error. So in this example, I use the flag -lazy. So Clang doesn't know -z. He doesn't know this flag. So he's going to return an error, and he's expecting a single argument. So he's saying that I cannot find this file. So instead, we decided to accept this flag and to pass it to the linker. It's very easy to access C-Lang code to do that. So we have a list of flags that we know that are not for us, but are for the linker. We are forwarding automatically that to the linker. So we fix a few of them. So we tried another way to improve the code. So the idea was to, instead of only hacking in Clang, also hack into GCC. So the first example, I don't know how to go back on this one, whatever. One of the first examples that I show you with a return was the return which are not triggering any warning when they are used incorrectly. So I try to hack into GCC to do that. So I've got a 1000 file modified patch waiting, but it's very tough to get patch applied in GCC. One of the side effects of the huge test suite of GCC, it is very hard to modify some basic behavior because you have to update all tests in the GCC test suite. And the test suite takes forever to run. Clang takes 3 or 4 minutes, but GCC is something like 6 or 5 hours. So I tried, but I have to go back on this subject. It was a bit boring. It's easier to hack in Clang, but I really want to get that fixed in GCC. I think that it will improve every software when we start to add more warning by default. So the last rebuild that we did proves that Clang is now ready. We don't have too much hacking to do in Clang, but most of the problems are upstream. So as you know, we have plenty of dead upstream in Debian, stuff which are very used and used on a daily basis. But upstream is dead, so it's hard to get the patch applied upstream, and the maintainer of the package, sometimes they don't want to take the risk to update the package. I know that in Debian we have the experience to break stuff by applying patches on top of upstream. I did that myself many times. If you want to find out all the results, so we have been publishing the results for the last 2 years, something like that, so you can find every rebuild, all the log available. All the data are public, and everything is published on this URL. And we are using the Amazon cloud to do the rebuild. So in Debian, we have something like $10,000 free credit on Amazon to do some experiments like this one. It takes something like 10 or 12 hours to rebuild the whole archive using something like 50 nodes. Yeah. So I'm going to talk on some things that I haven't done. I know the folks who are doing that. We are working together, but I haven't been able directly in this project. So I'm going to talk about the LLVMLinux project. So the goal is obvious, is to use Clang to rebuild the kernel itself. And we are using the same approach here. So they are hacking into the kernel source code. And in the meantime, they are updating Clang to support some black magic that I don't understand. It's something to do with low-level code and context switching and so on. So they are working on both sides. So they have currently, the number I looked this morning, they have 69 patches maintained on the top of the kernel tree. So they are updating the build system. They are also updating the code to manage the variable length array in struct, because I know that applying the patch makes sometimes the code way dirty than it is using this kind of trick provided by GCC. There are also a bunch of nested functions. So some maintainers, they don't want to care about Clang, so they don't apply the patch. So the LLVMLinux guy has to maintain them. And if you want to help to get the patch applied upstream, I gave you the URL. So they will be very happy if you can help them to apply those patches upstream. But I know that Linus is very interested by their work. He has been attending to all the talks at the last Linux Plumber, so he's pushing a lot on this to get that working at some point. So they have the working kernel on some architecture. I put ARM64. I'm just guessing. I'm pretty sure that they have that, but don't complain if they don't. And the Intel CPU has been working for a while, at least 1 year. And they still need to apply a bunch of patches upstream now to get everything ready, up and running. They are also running some continuous integration on the kernel, applying the patches daily to make sure that nothing regrets from where they are. And they are very cool people, so that's great. So here is for my lightning talk. If you have any question, don't hesitate. Okay, cool. Yeah.
So, do you know exactly what are the main things left for having a and features missing compared to the standard Clang?
You mean in the work of rebuilding or making Clang the default compiler for Debian? Or in which context? Clang is already ready. For example, Firefox and Chrome are both built under Mac OS X using this compiler.
But from what I understand, they had to patch the kernel in order to make it more
Yeah.
Clang. So what is actually the Clang? Are they just making something like as a fork, or
No, no.
are they actually...
Their goal is to have all the patches applied upstream. But you have to convince people, you have to make them understand that it makes sense to have your code built by two compilers and so on. And it is not technical now. I see that more as a political problem and pushing people to apply their patches and so on. Because I saw that some patches, I saw some patches that they've done. The code is way more dirty after the patch. It's really the case with variable length array. Because there is no easy way to do it. I saw this morning a few of them. Maybe it is just that they haven't pushed them for upstream yet. I'm just doing the advertisement for them, so I'm not involved in that project. So maybe I say many mistakes during my talk about their work, but yeah.
What's the goal of having an alternative compiler? Is it that it's supposed to produce better code in the end, to compile faster, to detect different classes of bugs?
So for me, to be clear, the first goal for me, it was to have fun. I don't care about the fact that one is BSD and the other one is GPL. It is just a new compiler, it's fancy, it's fun. It's very interesting to work on a base code like this one. So that was my initial goal. So now I see that first, it is better to compile with two compilers because Clang is giving some warnings that GCC is not. So for this first goal, it is interesting in terms of quality. For now, Clang is still producing binary which are slower than GCC. So we are not going to make any switch for that. And it was not my idea, but some people in the Debian community contacted me and say, okay, maybe we are going to switch this architecture with Clang. Because, for example, ARM folks are investing a lot in Clang. So maybe at some point, the ARM support is going to be better with Clang than in GCC. So maybe at some point in Debian, we could have one architecture which is built with GCC and another one with Clang. I don't think the architecture is ready. The infrastructure in Debian is ready for that, but we could do that. We could do that at some point. Yeah. No, in Debian, what we do in this case, we report bugs by hand. Because we have no way to know if the bug has been reported before and so on, and since we are maintaining many architecture, it's a mess. So we don't have any way to automatically report a bug when a package is failing to build from sources. Yeah, we do search for that. Yeah, for sure. Yeah, for example, on the LLVM2 chain, I'm applying something like 60 patches on top of the package. So it's usually that we do because most of the Debian developer, we are very busy and we don't take the time to upstream the patches upstream. The patches that I wrote after them are very crappy, and I would be too ashamed to see them apply upstream, so I'm not going to forward them because we are coding stuff for Debian. Yeah, but you have to find what is the email address. You have to do that for every package that you maintain. You have to send some clean package because otherwise you will be flamed by them. Yeah, I agree with you that it is a shame. I'm just explaining why we do that this way. I'm not saying that it is the right way, but I think the Mageia folks, they have the same issue also. It's hard when you maintain a full distribution to forward every patches upstream. Yeah. So I haven't looked in specifics, but I know that most of them are working. I know that the glibc is not working. It's not building with Clang yet. I saw some discussion on the mailing list, and it is the same. It's a variable length array and some inner function. And I guess the kernel, because we are enabling many different features, is probably not building either. But we don't have too many big projects which are failing. Yeah.
In the context of a distribution, can you mix and match packages compiled with one compiler?
Yeah, some maintainer are already doing that. For example, Clang, while it is done in C++, is using less memory than GCC. And on some packages, on some architectures, the build machine have something like 1 or 2 gig of memory, and the test suite is failing, so they switch to Clang to build the package because it's using way less memory. So yeah, it's common. But it's some scientific package which are using plenty of templates, stuff like that. I'm mentioning packages that I know which are doing that, but it's tough to know automatically in Debian which packages are using Clang to build. Yeah. Yeah, but sometimes it is using the library and so on, so it's tough to know. And I would have to dig inside to know if they are just using some library or if they are really building with that, and if it is for one architecture and so on. Yeah.
What about the cloud static?
So we did that. We have an infrastructure to do it. But the patch that we are applying are very hard to maintain because so the Clang static analyzer is using the C flag and the CXX flag. So if upstream is not respecting and honoring those flags, the Clang static analyzer is going to fail. And many upstream projects do not respect the C flags and the CC and the CXX variable. So we did that, but the result, you have to dig into the result to find out if Clang didn't find any issue, which is usually not the case because it is always able to find some issue in the source code, or it is because upstream is not honoring the CC and CXX variable. So we did that, but the result needs to be cleaned and so on. But yeah, it's a very interesting project, this one. Well, if you don't know the Clang static analyzer, it's a great project. You can find many errors for you. Okay, cool. Thank you.